Alright, welcome back to another review video. We're doing retakes, people. Okay, so we're on target 6B, which says given geometric figures, use rigid motion to determine congruence. So remember that word congruence means same size and shape. Okay, so same size and shape. So for number 1, it says determine the value of y. So determine the value of y that maintains congruence of the figure. So that means we're trying to make figure 1 congruent to figure 2. Okay, so we're trying to figure out the value of y. So here's the variable y. We have to figure out what number y is in order for these two quadrilaterals to be congruent. So in order to be congruent, same size, same shape. So this side has to be the same as this side has to be the same as this side, the third sides have to match up, and the fourth sides have to match up. So when this happens, that tells us that this side over here and this side should be the same length. So we have to figure out what number y needs to be in order to make that whole thing end up being 19, because we want it to match the 19 over on the other side. So what we do is set up an equation. So we set up an equation where we set 3y minus 2 equal to 19, because we need to figure out what y is in order, let's make that a different color. We got to figure out what y is in order to make that whole side 19. So we're going to set up our equation. We separate our two sides so we know we're always doing the same thing to both sides. And then we're going to go ahead and solve it. So we're going to add 2 to both sides in order to do the opposite operation of minus 2. So we have now 3y equals, and then 19 plus 2 is 21. And now we have 3y equals 21, so we're going to divide both sides by 3, and we get y equals 7. So our directions said determine the value of y, and that's what we did. Okay, so it says describe the path that would map the pre-image to the image using a combination of at least 2 transformations. Justify whether or not the image and pre-image are congruent. So we need to say how we got, it doesn't really give us which one is the before and after, so we'll say this one is the pre-image and this one is the image. So we want to see how do we get from the shape looking like this, how do we get from the shape looking like this to looking like this, right? So we can kind of think of it as a combination of 2 things. So we can kind of see, well, the picture is flipped. So 1, it started kind of facing up and it flipped to face down. Then also, if it just flipped, like this side would be touching. So it flipped and then also moved. But we have to use the proper words for flipped and moved. So flipped is reflection and move is translation. So those are the 2 transformations. Then it also says, second part, justify whether or not the pre-image and the image are congruent. So we would say yes, they are. I'm going to use the symbol for congruent, right? They're congruent. Because they are the same size. Ooh, my pen didn't want to work. Size and shape. Right? We know they're the same size and shape because reflections right, which is another word for flips. So reflections are flips, and reflections and translations. So another word for translation, that's when it slides. So when you flip it or slide it, it doesn't change the size or shape, right? So that's how we know they're the same size and shape, because if we flip it or if we slide it, that doesn't change how big or small it is, and it doesn't change the actual shape that you have. All right, second one, or number 3, my bad. It says describe the transformation that maps the pre-image to the image. So in A, right, look and see at all of these. You see with all of the ones on the second one, they have those little apostrophes. So that shows you that this one is the image, right, or the new one. And this is the pre-image, which is the original, OG. So we have to see, well, how did we get from the original to the new one? Well, it looks like, did it flip? No, because C is down here and C is down here, and A is here and A is here, so nothing was flipped, and also nothing was turned because the triangle is still facing the same direction. It just moved to a different location. So move to a different location, we'd say it just moved, which is a translation. Okay, and then this next one, we have the pre-image and the image. So remember, the pre-image, that's the original, and the image is the new. So we can see that it was flipped, right? It started facing this way and then it got flipped upside down. So that is a reflection. All right, then last one, we have triangle ABC has the vertices. It gives you kind of the coordinates. So A is at 2, 0, B is at 2, -5, and C is at 2, -2. It says a translation, right? So a translation, so that means the triangle was slid. Ooh, that doesn't look like a triangle. Wow, that whole word was, there we go, was slid. So the triangle was slid, and point A, so point A moved to 3, -3. So you see the difference. So this one doesn't have an apostrophe and this one does. So this is the original and this is the new one. So the new location for point A is -3, 3. It says, what are the coordinates for B? And look and see, the B has that apostrophe, so that means where's the new location for B? Explain your reasoning, including the change in X and Y. So when you have a triangle, if A moves a certain amount, then B is going to move the same amount because that triangle is always connected. Okay, so if we kind of track how A got from its OG position to its new position, then we can also figure out, we know B's original position, we can figure out where it ends based off of what happened to A. So point A, right, we see the original location right here, just plain A. The original location was 2, 0, okay? Then it told us the new location, right, is -3, 3. And in both of these, right, the X and Y, So we're going to map out how we got the X and then map out how we got the Y. So how do we get from 2 to negative 3? You go down 5, because if you're starting at 2, you have to do what to get to negative 3? You have to subtract 5 to get to negative 3. So that's what happened. That's what happened to all the x's. And then we do the y's, and we see we go from 0 to 3. So we go to 0, we have to think, what do we do to end up at 3? You add 3. So that is what's happening to the y. So we see from this that for the x, you subtract 5, and for the y, you add 3. Okay? So now we're going to go and do it for b, because we have to figure out where b ends up. It says we need to find the new location for b. Well, if the for a, if the x moved negative 5 and the b moved positive 3, the same thing's going to happen for b, because the x and the y, the triangle's all connected, so it's going to move the same amount no matter which a, b, no matter whether it's point A, point B, or point C. It's all connected, so it's all going to move the exact same amount. So we look over here. B's original location is 2, negative 5. So B's original location is 2, negative 5. What we're trying to figure out, what the new one is, right? That's our goal. We're trying to figure out what is the new location. Well, we have to use the same path that the other one took. So it has to, the x has to move the same number of steps, and the y has to move the same number of steps. So we have to take, the x has to move the same number of steps, so the x has to go down 5 again, and then, right, the y also has to go the same number of steps that it did before. So the y has to go the same number of steps, so it has to go up 3. So then we do 2 minus 5. So 2 minus 5 is negative 3. And then to get the new y, we do negative 5, because that's where it started. We go up 3, gets us to negative 2. So the new location for B is negative 3, negative 2. Alright, that's all. Go ahead and go to your retake.